Hawaii's Big Island still has no power in some districts. Crews are still hauling debris off the roads from Hurricane Lala, and the National Hurricane Center has already flagged a new tropical system forming in the exact same stretch of ocean. Nearly a week after Lala hit, somewhere between 17,000 and 24,400 customers sit in the dark. That is roughly the population of a small city, with no lights, no refrigeration, no working well pumps. The new system carries a label, Invest 90E. Forecasters give it a 70% chance of becoming a tropical depression within 48 hours. It is moving west-northwest at 10 to 15 miles per hour. That heading points it at the same windward slopes Lala already soaked with 15 to 20 inches of rain. This is not a coincidence. Something significant is happening in the Central Pacific this year. Today we are going to break down exactly what Invest 90E is, where it's headed, and what it means for an island that hasn't finished recovering from the last storm. No guessing, no dramatizing. Just the facts, the science, and the real stakes for the people living through this right now. If you have lived through a Hawaii hurricane season, or any stretch where the next warning arrived while you were still cleaning up from the last disaster, describe that feeling in the comments. Other people watching need to hear it in plain words. Invest 90E's track will shift over the next 2 days. Earth Dispatch will post the moment the Hurricane Center names this system or upgrades it, so subscribe if you want that update the hour it lands. Lala went from a tropical storm to a major hurricane in roughly 48 hours. 2 days. Forecasters call that rapid intensification, which simply means a storm's winds strengthen dramatically in a very short window, faster than most people can react to. Lala peaked as a Category 4 hurricane over open Pacific water. Those winds can strip a wood frame house down to its frame and shear mature trees off at the trunk. Satellite images that week showed a clean, tight eye at the center. Anyone watching the loop understood what was sitting offshore. Then the ocean and the atmosphere did what they often do near Hawaii. Cooler water and stronger high-altitude winds cut into the storm's structure and pulled it apart from the top down. By the time Lala made its closest approach to the Big Island, it had weakened to a Category 1 hurricane. That sounds like relief, and in one real sense it was. A Category 1 does not flatten neighborhoods the way a Category 4 does, but the wind speed at the center is only part of the story. On a volcanic island where the land climbs thousands of feet straight out of the sea, it is often the smaller part. The wind readings tell you what happened at elevation. Instruments at the summit of Mauna Kea clocked a gust of 140 miles per hour, a record for that site. 140 miles per hour is fast enough to roll an unsecured vehicle, peel steel roofing off a building, and turn loose gravel into projectiles that crack windshields. Lower down in South Kohala, a gust reached 80 miles per hour. That is enough to snap wooden power poles and drop full-grown trees across 2-lane highways. Across the channel on Maui, Olowalu logged 74 miles per hour. Those last two numbers came from places where people live, drive to work, and run businesses. The rain did the deeper damage. At its heaviest, Lala dumped water at about 5 inches per hour. 5 inches in 60 minutes is more rain than many mainland cities collect in an entire month. Windward Big Island picked up 15 to 20 inches in total, with isolated pockets over 30 inches. Windward means the side of the island facing the direction the wind and storms arrive from. On the Big Island, that is the eastern and northeastern flank, where the ground rises fast, the gulches run steep, and water has nowhere to go except downhill in a hurry. 30 inches is 2.5 feet of water falling onto slopes that were already green and wet before the storm arrived. Streams that normally run ankle deep turned into fast brown rivers inside a couple of hours. Floodwater lifted 2 homes clean off their foundations and carried them away. Across the state, officials counted more than 100 homes damaged or destroyed. Behind that number sit families who came back to a slab, a mud line on the wall, or a driveway that ends in a washed-out gulch. The grid took the widest hit. At Lala's peak, 200,000 customers across Hawaii lost power. A customer is a meter, not a person, so one account can mean a family of 4, a rented apartment, or a small shop with a walk-in cooler. Stretch that out, and you are looking at a large share of the state's roughly 1.4 million residents losing electricity in the same afternoon. Traffic lights went dark. Water systems that depend on electric pumps stopped. Anyone on a home oxygen machine or a refrigerated medication started counting hours. That was the storm. What matters now is where the recovery actually stands. But to understand why this new system is such a problem, you have to understand exactly what the island is still dealing with. As of August 19th, the same day forecasters flagged the new system, between 17,000 and 24,400 customers on the Big Island still had no power. That is day 6 and day 7 for those households. The Big Island is home to a little over 200,000 people, so this is not a scattered handful of remote cabins. Whole neighborhoods are running on generators, coolers, and whatever fuel the nearest open station has left. Right now, those same households are the ones directly under the forecast cone of the next system. 21 transmission lines took damage during Lala, and crews have repaired roughly half of them. Transmission lines are the large, high-capacity lines that carry electricity from generating plants to entire districts. When one of those fails, it does not darken a street, it darkens a region. Restoring them is slow, technical work that often happens on ridgelines and in gulches with no road access, which means helicopters, hand crews, and daylight-only hours. Half repaired is real progress. It also means half are still down. Utility crews have given a 2-week restoration estimate for the hardest-hit districts: Puna, North and South Kohala, Naalehu, Punalu'u, and Volcano. Puna alone holds more than 51,000 residents, many of them on catchment water systems that need electric pumps to deliver anything to a tap. Volcano Village sits near 750 people at around 3,750 feet elevation, where nights turn genuinely cold. Naalehu is a town of a few hundred with one main road through it. 2 weeks from August 19th lands well into September, which means these districts could still be dark when the next system arrives. Along the Hāmākua coast, north of Hilo, crews are working through 42 miles of downed lines and poles. 42 miles is roughly the drive from Hilo to Waimea, and that coast is the hardest possible place to do this work. The highway threads along cliffs and crosses deep gulches with sugarcane-era bridges and few detour options. If a repair truck cannot reach a pole, the pole waits. Every mile of that 42 has to be walked, cleared, restrung, and tested before the lights come back on. Southern Big Island is dealing with 8 damaged bridges. On this island, a bridge is not a convenience. Highway 11 and the smaller roads that feed it cross dozens of gulches, and most of those crossings have exactly one span. Damage one bridge and you can add an hour to an ambulance run, cut a fishing village off from its grocery store, and stop a lineman's bucket truck from reaching the pole it was dispatched to fix. 8 of those crossings are compromised while the ground underneath them is still saturated. Residents have filed 263 residential damage reports and 18 commercial reports with Hawaiʻi County. Every one of those 263 is a household sitting down with a phone and a form trying to describe a flooded floor or a missing roof to a county worker. The 18 commercial reports represent the small businesses that employ people in towns where there is no second employer down the street. Hawaiʻi County itself only just resumed non-emergency operations, with offices reopening Wednesday, August 21st, which is when permits, inspections, and aid paperwork start moving again. So crews are still working through downed lines, damaged bridges, and a backlog of damage claims. Meanwhile, meteorologists are already watching the next system organize. What exactly is this new system they are tracking? Invest 90E is not a storm name. It is a filing label. When forecasters see a cluster of thunderstorms over warm water that looks like it might organize, they designate it an invest, short for investigation, which lets them point computer models, satellite tools, and aircraft data at that specific spot. The numbers cycle from 90 through 99 and repeat all season. The letter E marks the Eastern Pacific. So the label tells you one thing clearly. Professionals are actively studying this, and it does not yet have a name because it has not yet become a storm. The National Hurricane Center gives Invest 9OE a 70% chance of becoming a tropical depression within 48 hours. That is their own wording in their own highest category, which they describe as a high chance. 7 out of 10. Put another way, in a similar setup 10 separate times, 7 of those systems would close off a center and get an official designation within 2 days. Forecasters do not hand out that number casually. It means the satellite structure and the environment around it both already look right. The fuel is there. Sea surface temperatures across that part of the Pacific are running warm, and a tropical system needs ocean water around 80 degrees Fahrenheit, roughly 26.5 Celsius. Warm to some depth, not just at the surface. Warm water evaporates into the air, that moisture rises, releases heat as it condenses into clouds, and that released heat is what spins a disturbance into a storm. Cold water starves the engine. Warm water feeds it. This year, that water has been feeding almost everything that crosses it. Wind shear is the other half of the equation, and right now it is unusually low south and southeast of Hawaii. Wind shear means winds blowing at different speeds and different directions at different heights in the sky. High shear tilts a young storm sideways and rips its structure apart before it can organize. Low shear lets the thunderstorms stack up neatly on top of each other, which is exactly how a disorganized cluster becomes a rotating tropical depression. Forecasters are watching that low shear pocket build in precisely the corridor this system is crossing. Invest 90E is tracking west-northwest at 10 to 15 miles per hour. That is slower than most people ride a bicycle, but sustained around the clock it covers 240 to 360 miles a day. This gives Hawaii a timeline measured in days rather than hours, which is genuinely useful for anyone stacking water or moving equipment. It also means the system has days over warm water with little to tear it apart. Time over warm ocean is what turns a disturbance into something with a name attached. Forecasters have made one point repeatedly, and it is the most important part of this whole story. Where the exact center passes matters far less than where the moisture goes. A tropical system drags a wide plume of extremely wet air ahead of and around it. When that air hits the windward slopes of the Big Island, the terrain forces it upward, it cools as it climbs, and it rings out as rain. That happens whether the center is 50 miles offshore or 200. The mountain does the squeezing, not the eye. That is why forecasters have named flash flooding and mudslides specifically. A flash flood is flooding that arrives within hours, sometimes minutes, of intense rain, and it is at its most dangerous on steep ground where water accelerates instead of spreading out. The soil on those windward slopes already took 15 to 20 inches from Lala. Saturated ground behaves like a full sponge. It cannot absorb more, so almost everything that falls becomes runoff immediately, and waterlogged hillsides slide far more easily than dry ones. If this system organizes west of 140 degrees west longitude, it moves into the Central Pacific Basin and takes the next name on that list after Lala, which is Moke. That has not happened yet. Nobody should be posting the name Moke as fact today. And if that rain arrives, it is aimed at Puna, Hāmākua, and Kohala, the exact districts with 42 miles of downed lines, 8 damaged bridges, and a 2-week wait for power. None of this happens in a vacuum, so here's how rare this timing actually is. The closest precedent on record is 1992. Hurricane Iniki tore into Kauai on September 11th of that year as the most destructive hurricane in modern Hawaii history. 3 days later, Tropical Depression Orlene moved through the same waters while the island was still counting bodies and clearing roads. 3 days is the tightest back-to-back tropical threat Hawaii has documented, and people who lived through it still talk about the second warning more than the first. There is one other comparison worth naming. In 1982, 2 tropical systems approached the islands roughly 10 days apart, and both were considerably weaker than what 1992 delivered. Beyond those 2 seasons, the record is thin. Meteorologists describe multiple tropical systems reaching Hawaii within days of each other as effectively unprecedented in the satellite era, meaning the roughly 60-year stretch where we have had continuous eyes in orbit and can be confident nothing slipped past unrecorded. The wider season explains why this is happening now. The Central Pacific Basin, which runs from 140 degrees west longitude out to the international dateline, has produced 7 named storms so far in 2026. Compare that to 2 in all of 2025 and just 1 in 2024. 7 in one season against 3 across the 2 previous seasons combined is not a small fluctuation. That is a basin behaving differently, and every one of those systems crossed the same warm water and the same low shear corridor that Invest 90E is crossing right now. Scientists do not yet know how much of this belongs to a single unusually warm season and how much reflects a longer shift in Pacific patterns. That question takes years of data to answer honestly, and anyone giving you a confident answer today is guessing. What forecasters can say with confidence is narrower and more useful. The ocean heat is measurably there, the shear is measurably low, and those 2 conditions together have allowed system after system to survive the crossing this year instead of falling apart. On the ground, this creates a resource problem that rarely makes headlines. The Hawaii Emergency Management Agency and the National Weather Service Honolulu office are now tracking 2 things at once: an active recovery and a developing system. Utility crews face a hard operational limit as well. Bucket trucks cannot safely lift a worker once winds past roughly 30 miles per hour, so if Invest 90E's outer bands reach the island, restoration work stops for the duration. Every hour of stand-down pushes that 2-week estimate further out. The realistic worst case here is not a second hurricane disaster, and it would be dishonest to sell it that way. The far more likely outcome is renewed flash flooding on already saturated slopes, fresh mudslides across roads that crews just cleared, new debris on lines that were about to be re-energized, and a power restoration timeline that slips from 2 weeks toward 3. That is not cinematic. For a family in Puna on day 7 without electricity, it is the difference that actually matters. Which brings this to the real shape of the story. This was never mainly about one storm's wind speed. It is about an island that has not been given a window to recover before the next system arrives. What does all of this actually mean for the people on the ground? Put the 2 situations side by side. In 1992, Kauai got 3 days between Iniki and Orlene, and that gap has stood for decades as the tightest sequence in Hawaii's record. This time the gap is closer to a week, which sounds like an improvement. On paper, it is. But 1992's second system arrived at an island where the grid had been destroyed and rebuilding had barely begun, and today's arrives at an island where 17,000 to 24,400 customers still have no power, 8 bridges remain damaged, and 42 miles of line still lie on the ground. More days on the calendar, arguably less resilience on the ground. That is the part worth carrying away from this. The strength of any single storm is only half of what determines the damage it does. The other half is timing, and timing is something no forecast can improve. A moderate system that arrives during an unhealed recovery can cost more, break more, and hurt more people than a stronger one that arrives with a full grid, clear roads, and 2 weeks of warning. Preparedness is not a category number. It is whether the crews finish the last job. If you live somewhere that gets hit repeatedly, hurricane coast, wildfire country, a floodplain, tell me which part is genuinely harder, the disaster itself, or never getting a full recovery window before the next warning drops. That answer says more about disaster response than most official reports do. Earth Dispatch will post the moment Invest 90E gets upgraded or named with the updated track and the districts in the path. Subscribe so that update reaches you instead of a rumor. And send this to anyone with family on the Big Island right now, because the people in Puna and Kahala deserve better information than a screenshot with a name on it that nobody has officially issued yet. Because that is the pattern now. The rumor moves faster than the forecast, and the forecast moves faster than the response. Somewhere in that gap, a family in Pahoa decides whether to fill the truck tonight or wait until morning, and they make that call based on whatever crossed their screen last. That is not a failure of the people making the decision. That is a failure of the pipeline feeding them. So here is what actually matters in the next 72 hours, stripped of the noise. Watch the sea surface temperatures along the track corridor, because that is the fuel gauge. Watch the wind shear forecast east of 140 west, because that is the break. And watch whether the mid-level ridge to the north holds its position, because that single feature decides whether this system curves harmlessly into open water or gets steered toward the islands like a ball rolling down a tilted table. 3 variables, everything else is commentary. What makes the Big Island different from almost anywhere else in the Pacific is that it builds its own weather. Mauna Kea and Mauna Loa are not obstacles a storm goes around. They are walls nearly 14,000 feet high sitting in the middle of the track, and they tear circulation apart while wringing every drop of moisture out of it. That is why a weakening storm can still be catastrophic there. The wind field collapses and the rainfall totals go up. Hilo has recorded rain measured in feet, not inches, from systems that were technically falling apart on paper. Downgraded does not mean safe. It means the threat changed shape. And the terrain that squeezes out the rain also decides where it goes. Water coming off those slopes does not spread out. It channels into gulches that were dry that morning, and it arrives with the speed of something that has been falling for miles. People who have lived there their whole lives will tell you the same thing. You do not watch the sky, you watch the stream. By the time the gulch is loud, the decision has already been made for you. Then there is the part nobody puts in the graphics. 2 deepwater ports serve this island, and if either goes down, the shelf clocks start running. Roughly 80% of what people eat arrives by ship. Fuel arrives by ship. The medical supplies arrive by ship. A storm does not have to destroy a single house to change life on that island for a month. It only has to keep the harbors closed. That is the story we will keep following, whether or not Invest 90E ever earns a name, because the name was never the thing. The name is a label we attach after the physics has already decided what it intends to do, and the people in the path do not get to wait for the label before they act. So take the 45 minutes today. Water, batteries, medications, documents in one bag, gas above half, a plan for who calls whom when the towers drop. If nothing comes of this system, you have lost an afternoon and gained a kit that will still be sitting there next season. If something does come of it, you will have bought yourself the one thing that never shows up in a preparedness list and matters more than any of it. Time to think clearly before you need to.